In this section, we are going to add and subtract radicals. So in this first example, we have a subtraction problem. Before we do this, I want you to picture something similar. Imagine I were to write 4x minus 3x instead of square root of 7. Whenever you deal with things like this, you always are combining like terms. So 4x minus 3x would be 1x. You would do 4 minus 3, and then you would keep the x. And mathematically, if you're wondering why that actually works, it's because they have an x in common that you could pull out front and then factor that out, leaving you with 4 minus 3. And well, 4 minus 3 is just 1, and 1 times x would be 1x, or just x. We're going to take the same approach here with the radical. So 4 root 7 minus 3 root 7 is equal to 1 root 7. Again, mathematically, if it helps you visualize it, you could take that root 7 and say, oh, that's in common. I'm going to factor it out, leaving me with 4 minus 3, which is 1. And 1 times root 7 is 1 root 7. So a few different ways of thinking about this, but think of it the same way you think about terms with x when you're adding and subtracting terms with x in it. Let's try another example with a common denominator. We have 5 root 10 minus 2 root 10. Well, 5 minus 2 is 3. So then 3 root 10 is our answer. So not too bad so far. Go down to another example. We have a negative 2 and a negative 4. So we have both of them being negative. You have to be careful. Negative 2 plus a negative 4, or negative 2 minus 4, same thing. It's going to be negative 6. And then you still have your common root, square root of 6. You're not going to multiply these because we are not multiplying. We are adding and subtracting. So the way I like to think of it is everything is addition. You're just adding negative numbers, and I find that a lot clearer. So this one here, negative 6 root 6. Now we have something interesting happen because that square root right there is not the same as these. In the same way that imagine you could have something like 3 root 6, or excuse me, 3 negative 3x plus 3y minus 2x. If you had something like that, you would not combine the x and y's. They are unlike terms. So what you would instead have to do is just focus on the ones that share the x, so the negative 3 and the negative 2. Add those together, you get negative 5x. Or in our case, negative 5 root 6. Then right here you have this oddball one that just kind of comes along. 3 root 5. So you would leave that, and you cannot simplify any farther. Your final answer for that is negative 5 root 6 plus 3 root 5. They never can combine. Moving on to this next example, we have the same issue, except these roots can be simplified, so maybe there's something that we don't know about. If we look at 12, 12 breaks down to 4 times 3, and 4 breaks down to 2 times 2. So when I look at this, I see a pair of 2's and a leftover 3, meaning that this first root has a negative out front. Don't lose that. That's like a negative 1. Negative out front. And then it has a pair of 2's under the root, which becomes just a single 2 outside. And then it has the 3 left behind. The next one is an 8. 8 is 2 times 4. 4 is 2 times 2. So I have a pair of 2's and a leftover 2, and the other ones are all broken down. Out front I have a negative 3, so I have to be careful not to lose that. So I have negative 3 times pair of 2's times square root of the leftover 2. And then finally at the end, 2 root 2. I can't break that down, so I just 2 root 2. When I look at what I have, I can clean up negative 3 times 2 as negative 6. So I'm going to just do that right here. Negative 6. And then I look for common roots. I have my root 3, but then I have my other roots, my root 2. So the numbers out front of those can be combined, whereas the numbers out front of the other one need to be treated separately. So I'll write out my first thing, -2 root 3, and then I have the -6 plus 2. -6, +2 together make -4 common root square root of 2. Do one more example here. This one's a little bit more straightforward because we don't have any radicals that break down. And in fact, we have only a couple in common, so these are both like terms, and that -root5 is something different. So -root5 or -1 root 5. And then 2 minus 2, or +2 plus -2. Well, that equals 0. And 0 times the square root of 2, well, 0 times anything is 0. And if we add that on to what we have, anything plus 0 is just itself. So that's it. That's our answer. So when things like that happen, poof, -root 5.